Alright, so page 140 in your book, we have 5jk squared plus 5j squared minus 2j squared k, and then minus jk squared plus 2j squared k plus 5j squared. The biggest part of this problem that the testers love to see if high school students can get is that right there. Can someone tell me what sign is in front of this parentheses? A positive. So nothing changes, right? None of these change whatsoever if a positive is distributed. But these definitely change. A negative and a positive, a negative and a positive, and a negative and a positive. So this becomes minus all of this. Do you see what I'm saying? So let's move this down, and then you guys can see what I'm talking about. So this will change, this will change. Now you have minus, minus, and minus. Since nothing changes on this, I can take the parentheses off, and now all I have to do is combine like terms. You with me? So let's combine like terms. First of all, just a little premise. What's that? 11x. What's that? Is it 12xy? No. You can't add them because they're not like terms, right? So this one we need to find our like terms. So we have j squared, j squared. They cancel out to what? 0. Perfect. And then now I have j squared k, j squared k. Do those cancel?
No.
They become what?
-4j squared k.
Perfect. And now jk squared, they're different. They're not, these are all different. If I have 5 of them here, how much would I have total? 4, because it's just subtracting 1. And that looks like it would be your answer, which is what, B? Yeah. You see it? Okay.
Yeah.
What other problems from the book? Alright, so in your book, on page 160, this is a non-calculator kind of problem. So the manipulation with these properties, you definitely need to know how to do. So here's what I'll say. What this question is testing is Algebra 2 knowledge that exists with the following. Let's say that I had x squared times x to the third. What do you think that equals? Okay, so x to the fifth or x to the sixth. This is x to the fifth. Okay? This is what x to the sixth looks like. And if you need to put it in your notes, please write it down. The best way to remember it is that 2 and 3 are separated with the parentheses. And most of the time that we use parentheses, what do? We multiply. So that's how we would multiply to get a 6. Okay? Otherwise, the rule that you should know is x raised to the power of 2, x raised to the power of 3 when multiplied, you add the exponents. Okay? The other thing is this. If you had x squared divided by x cubed, it's x to the 2 minus 3. And some people get confused with this because they see this as x to the negative 1 and they freak out a little bit. Okay? Anything to a negative power, all you're going to do is move it across this line. Okay? So this is like saying x to the negative 1 over 1. And if I have a negative power, just like I said, I'm going to move this entire piece across the division sign, and I'm going to bring it downstairs to a positive 1. Okay? No, this 1 doesn't flip and come upstairs. It doesn't do that. It doesn't flip. But there is a 1 that's left over because it's understood there. You see what I'm saying? There's a 1 at the top no matter what. Like if I said, what number is in front of x, what would you say? 1. What number is in front of y, what would you say? 1. Because there's understood 1s that exist there. So this moved downstairs to be a positive. So the answer to this would be 1 over x. The easier way that I like to teach this is pretend like these were 2x's up top, 3x's on the bottom. Who wins? The bottom one does, right? Because these kind of kill each other off and cancel to a form of 1, right? So who wins? The one that's on the bottom. So it's just 1 to the power, or 1 over x.
Sir, I haven't been getting signal in this hallway.
Yeah.
I've only been getting signal around like the front of the school. Should I just pack my stuff up and go? Considering my dad's gonna.
Oh
take
yeah,
care of some
yeah,
of that.
yeah. Go for it. Yeah.
Thank you. I shall see you later.
Okay.
I'll see you tomorrow after school.
Okay. All right. So a powers with the same basis when multiplied, you add the powers. In parentheses, we will multiply. In division, we will subtract. There's one more that some people forget, is if you had something that looks like this. Let's say I have the square root of m over n. This is the same as this. Okay? And the reason why this is the same, it comes from this property right here. If I take the square root of something, it's the same as raising it to the 1/2 power. Okay? When I take the square root. If I took the cube root of something, it's the same as raising it to the 1/3 power. Yes, if I took the fifth, whoops, that's the third. If I took the fifth root of something, it's the same as raising it to the 1/5 power. So from this, what I'm trying to show you is that this is the same as if you wrote it like this. Okay? Now, right here, when we had a power raised to a power, we did in fact multiply these two together to get 6. This right here, it's almost like you're going to apply this to both the top and the bottom. You with me? So if you apply it, it becomes m to the 1/2 n to the 1/2. You will see this. And these are the same as the square root of m over the square root of n. Okay? So I know I'm showing you a lot, and I have to show you a lot because a lot is dealt with just this one little problem. So here we go. Let's go ahead and solve it out. A to the power of x divided by a to the power of y will equal this. From our property that we got down here. Are we good? From there, this property will help us with this piece. And what will a to the power of y raised to the power of 3 become? What will this become? A to the 3y. Yeah, because you're going to multiply. Because again, remember, the easiest way to remember is parentheses separates those. So you will multiply. So now is equal to a to the x. You with me? Okay, so what is it that we're solving for? A or x? We're solving for x. Alright, so if we're solving for x, what could we do from here as far as like our setup with everything?
You could plug it in.
Plug what in?
You could plug in the 8 to the x with a 3y minus y.
Okay, so we could say, so if we're plugging this, are you going to plug this in? Are you saying to plug this in like right here?
No, to the, well, yeah, or the a and the x minus y. Or is that together?
Yeah, this is together. This
Okay.
is a little bit different. I see what you were trying to do just now, but they are a little bit different, okay? So let's go ahead and plug in right now a to the 3y, where originally we saw a to the 3x. You with me? And then everything else is still the same. You see what I'm doing? So right now, everything's in terms of y. Okay? So what happens to these? What would that become? from our property that we have here? A to the 2y. Nice. So a to the 2y is a to the 10. Guys, if the bases are the same, we don't have to look at those anymore. Okay? Because we're trying to make them equal. So the only things that we have to look at is this. So what's y? 5. So y is 5, but we need x, right? So if I now plug in 5 for y, what's x? 15. So x would be 15. But guys, there's so much going on in this problem that's why I had to show you all the rules and stuff. So same bases when you're multiplying, you add their powers. A power raised to a power, you multiply those powers. If it's division, you're going to subtract those powers. And finally, with the square root, like I had written before, it applies to both the numerator and the denominator. What else?
On page 163, number 14.
That's a good segue. So 163, number 14, which of the following is equivalent to the square root of x cubed? Okay, so let me ask you this. What number is here? A 1. Okay. What does this equal? 2. What number is here? Not 1. A 2. So when I square root something, there's an understood 2, even though it's not written. But a lot of us like to think there's an understood 1, but it's a 2. So when I'm looking at this, you need to realize that there's a 2 there. Okay? And like I showed you, root 3 is the same as to the third. The fifth root is the same as to the 1/5. You see where I'm going with this? So how am I going to write this? X to the power of what? 3 over 2, right? So 3 will be the numerator, and the root below ground, if you will, you know, they're like the roots of a tree. Below ground is the root, and the power is powerful enough to stand above ground. Okay, so x to the 3 halves is what I have right there. You with me? So if it's x to the 3 halves, here we go. Let's test your knowledge from what we just did the previous slide. I'm adding, not multiplying, I'm adding these. Because I'm adding, do I add their powers? I don't. I don't. I only add their powers if I'm multiplying. Okay? So I will add their powers if I'm multiplying. And that's the same as 1 plus 1/3. You did a lot of homework over this recently. Have to multiply this by a form of 1. So it's 3/4. X to the power of 4/3. But it's not doing that. Okay? It's not multiplying. So we don't add the powers. But even if we did, this is nowhere near 3 halves. So we know A is not the answer. Or number 1 is not the answer. Okay? Let's do this one. 2. Roman numeral 2. Power raised to a power. What do I do? Multiply. What is 3 times 1/2? Here we go. What is 3 times 1/2? 3 halves, right? 1.5. Yeah, 3 halves. So 3 halves. And no worries, I know that it was easier in middle school just to do decimals, but I promise you they test you so much more with fractions. So that's why I always try to go to improper or simple fractions, just the top and bottom. And then last but not least, x squared times x to the negative 1/2. Because this is multiplication, what do I do with the powers? I add. So 2, and again, I'm not going to go for decimals. So 2 plus a negative 1/2, I need, look, common denominator. I don't have it right now. So I need to multiply the first one by a form of 1, which is what? What's the 2 over 2? Yep, 2 over 2. Because now I have 2, and it's common with that. What's the numerator right here? 4. So I have 4 over 2 minus 1/2. What does that give me? 3 over 2. So 3 works, and what else?
2 words.
And 2 works. So the answer is
C.
C. Any questions, guys? Awesome job today. That's all I have time